All right, so we've studied the basics about integrals now, and we've seen how to calculate an indefinite integral as well as a definite integral. And so now what we're going to do is actually apply that knowledge here to doing an application problem. And so if you remember from previous weeks, we've talked about marginal cost, okay? And so we know if we have an original function, f of x, and we want to find its marginal cost here, or let's say the marginal whatever of this particular function, then we would have to take the derivative of that, okay? And then if we wanted to figure out what the max or min or something is, we would take this and set it equal to 0 and find the critical points and all that good stuff, okay? Now we are actually going backwards. You're given what the marginal cost function is, but now we want to figure out the total cost. So to put that in another way here, you're given what f prime of x is, and we want to figure out what f of x would be, given this condition here. And so I'll go ahead and read the problem, and we'll work it. So problem says, suppose that the marginal cost in dollars for a company making widget Z is given by the function MC, which is 7x plus 10. And x is defined as the units made at one time on the assembly line. So in other words, this widget Z, we're making x units at a time. Okay. Find the cost, TC, if the company decides to increase the production of widget Z units from 10 at one time to 15 at one time, okay? Now, by us knowing that we have the marginal cost and we need to find the total cost, we know that we can take the integral of the marginal cost in order to get this. So we know that total cost would be the integral of marginal cost dx from 10 to 15, okay? And so filling in what we need to know, we know the marginal cost function is 7x plus 10. And so now this is just a matter of taking the antiderivative here. So if we take the antiderivative of this function here, this would be 7 times x to the 1 plus 1, which would be 2, divided by 2, plus, whenever we have a constant, we just say 10x. And so now we want to take that and evaluate it over from when x is 10 to when x is 15, okay? So therefore, doing that, we see here that we're going to evaluate this. We're going to plug in 15 in for x the first time, and then subtract it from, and then we plug in 10 the next time. So we're going to put 15 here, all that over 2 plus 10 times 15. And then we'll subtract that from doing the same thing again, but now we put in 10. All right. And so now it's just a matter of calculating at this point. And so if we do the calculations here, we'll have, I think this ends up being 1,000, oh, sorry, That's not correct. All right. So here this ends up being 1575 over 2 plus 150 and then this would be, let's see, 10 times 10 is 100, 100 times 7 is 700, 700 divided by 2 is 350 plus another 100. So 1575 divided by 2, go ahead and calculate that right quick, will be 787.5 plus 150 minus 350 and 100 is 450. And so we went ahead and calculated all that, you would end up getting $487.50. So what this says is that if we know that the marginal cost is represented by the function 7x plus 10, then the total cost, if we decided to increase production of widget Z from doing 10 at a time to 15 at a time, will cost us around $487.50 to do that. So that would be the interpretation of this particular problem. And this concludes this particular example and our discussion on the basics of integrals.